Hi, this is just a quick video on displacement reactions and looking at the reactivity series in terms of which metals will displace which. So we look at the reactivity of a metal by its tendency to lose electrons. The higher the tendency, the more reactive. And the more reactive it is, that means that it will lose its electrons better. So for example, if I was to have a metal very high up on my reactivity series, this means that it can lose electrons really well. So high on the series means it's highly reactive. And remember that in displacement reactions as well, metals are going to form positive ions as well. They will lose electrons. So we often look at displacement reactions with metals with elements such as carbon and hydrogen, because what they are often good at is extracting the metals from their oxides by reducing them. So we need to then have a little look at what this reactivity series is. So we're just going to be looking at some of the most commonly used metals. This is not exhaustive, but should help you with your exams. So first we've got the most reactive, which is going to be potassium. Then it's sodium. So this is the most reactive up here. We then have lithium, so hopefully you can see these are some of the group 1 metals which we know react very rigorously with water as well. Then calcium, moving into group 2 metals now. Magnesium. Aluminium, which is obviously a transition metal. We are going to include carbon because, like we said, they're useful for knowing which atoms and metals we can extract using them. I'll just write them in different colour. Remember, that's not a metal, but they are useful in our reactivity series. Then we have zinc, again another transition metal. Iron. Then we have hydrogen, again not a metal, but good for extracting metals in redox and reduction reactions. Then we finally have copper, which is fairly unreactive. Silver. And finally gold, which is generally so unreactive that you can actually find it in the environment as just gold without it being an oxide. So this is our list of reactive, from most reactive to least reactive. And this is important. So in a reaction, if you were to have a reaction between, for example, a potassium and an aluminium, the potassium is stronger, so it will stay bound to the compound, the aluminium wouldn't. However, if it was between, say, zinc and magnesium, and zinc was part of the compound, then that would be displaced by the aluminium because it is more reactive. So it's just remembering that if you have a more reactive metal, that will displace the less reactive metal by itself. So a metal in a compound has to be more reactive to stay in the compound. You will always end up with the most reactive metal in the final compound in your final product. So that's just a bit of a quick video on reactivity and displacement of metals.